All right, pre-calculus, here we are for your quiz 2.5 to 2.8 review video. And today we are brought to you by first food sponsors Bobo's, PB&J, Grape, gluten-free, Bodies the Temple. And then longtime sponsor Laura Bar. All right. Plant-based, gluten-free, dairy-free, vegan. Oh my gosh, huh? That doesn't say you on it already. And then by Harold S. Kushner, who also wrote When Bad Things Happen to Good People. 9 essential things I've learned in life as our first literary sponsor today. And then in our classroom hero here, David Goggins. Can't hurt me. Hashtag Goggins Grow. And finally, brought to you by today's college sponsor is Southern Illinois University. Go Dogs. Okay, here we are. Numbers 1 through 3. Solve each inequality. All right, anytime you have x squared in a inequality statement, greater than, less than, greater than or equal to, less than or equal to, you're going to want to make the u. You're going to want to draw this out. All right, so here we go. We got x squared plus 6x minus 16 is less than 0. You want to treat this as x squared plus 16 plus 6x minus 16 equals 0. So you're going to factor this. 1 multiplies 16, differs by 6. Positive 8, negative 2. Cover our method, x equals negative 8, x equals a positive 2. So then you're going to make your u. These are all u's because they're positive x squareds. And even if they weren't, you could just divide or multiply by negative 1 to make it such. We have an x-intercept at negative 8 and an x-intercept at 2. Makes a u. When is this curve less than 0? When is it under the x-axis? That's what it means to be less than 0, under the x-axis. And it's in this region. So first I know it's got to be negative 8 to 2. Then I ask myself, all right, is it going to be brackets or parentheses? Well, because it says less than means no equality. So it has to be parentheses. All right, so number 2, 3x squared. First off, you want to move everything over to the side with the positive x squared. So you're going to move this over. You're going to move this over. It comes now negative 14x minus 5. There's only one way to get 3x squared. This is if you have 3x and x. There's only one way to get 5. It's 5 or 1, or, 1 or 5. So you just got to guess and check. Put the 5 here, 1 there. So as we talked about in class, that gives you 15x, that gives you 1x. There's their way for 1x and 15x become a negative 14x. If you have a negative 5 there and a positive 1 there. 3x plus 1, I'm going to set it equal to 0. So again, treat this like it's equal to 0. I'm going to get x is negative 1/3, which is fine. You can have fractions. And then we have x minus 5 is 0, so x equals 5. So I got negative 1/3. I got 5 as my x-intercepts. Now this is saying greater than or equal to, so I'm going to be in this region and this region. Remember I called this region 1, this was region 2, this was region 3. So anytime I have above, it's going to be region 1 and 2. So I'm going all the way to the left for the x's, which is negative infinity. 2, negative 3. Now the reason I use a bracket because it says greater than or equal to, bracket time. Union from 5 all the way to the right again, which is infinity, but bracket around 5 because of the equality part. Not because it's greater than, but because you have equality. All right, number 3 is the same type of question. What multiplies 24 adds to a negative 10, negative 6, negative 4. Again, we have to be good at factoring. Factoring has got to be easy for us, especially what I call easy factoring. You don't have to guess and check, no AC method needed. So I have 2 intercepts here, x-intercepts 4 and 6. All right, again, it says what greater than or equal to. So I have region 1, I have region 2, I have region 3. It's above the x-axis here and in that region, okay? So again, this graph is going to the left. It is coming from the left, but if I head to the left, it's if I head up, it's up and to the left forever. All that to say is it's coming from negative infinity. X is negative infinity. 2, 4, okay. Bracket around it, it's greater than or equal to, union, 6, and then it's going up and to the right forever, and that's infinity. You always put parentheses around negative infinity or positive infinity. So that would be new for us this year. And then we get into questions which are most definitely not new for us. Absolute value, it's all about the distance from 0. Okay, remember you can live 3 to the left of the tracks or 3 to the right from the tracks. That's still a distance of 3. So I got to make sure my absolute value is all by itself, and I got to make sure it's equal to a positive distance. See, if I said the absolute value of 2x plus 1, or in this case, the absolute value of 2x plus 3 was equal to a negative 4, you would stop and you'd say no solution. All right, so I set what's inside the absolute value equal to 7. I set what's inside the absolute value equal to a negative 7, because I could live 7 to the right or 7 to the left. Then I subtract 3 and divide by 2, and I get my 2 answers. Anytime you have absolute value equations or inequalities, you're always going to get 2 answers, unless you have the rare case of no solution, or the even rarer case of actually living on the tracks, like having an absolute value set equal to 0. First thing I need to do here is I just need to subtract 2. Then I have an absolute value all by itself equals 7. That is fine. So I set 2 minus 3x equal to 7. I set 2 minus 3x equal to a negative 7. Subtract 2, divide by negative 3. Subtract 2, divide by negative 3. All right. Get my 2 solutions. Nice. And then don't judge it. Don't say no solution right away. Don't judge it too soon. I got to get rid of the 7. I got to add 7 both sides. And I have the absolute value of 3 over 2x plus 1 is equal to 6. So I set 3 over 2. 1.5x plus 1 equal to 6. And then 1.5x plus 1 equal to a negative 6. I subtract 1. Then I multiply by 2/3. Multiply by 2/3. So you could have fractions tomorrow. But guys, this is just a question from Chapter 1 of College Algebra. Chapter 1 of College Algebra was a review of Algebra 1. So honestly, that should not get us. Now we're getting into Chapter 4 of College Algebra here. Find all zeros, find all roots, find all solutions, find all x-intercepts. They all mean the same thing. So I'm going to let f of x be 0. I'm going to set this equal to 0. So x squared plus 8 is equal to 0. I'm going to subtract 8 from both sides. I'm going to take the square root of negative 8. That's plus or minus I root 8, which all your calculators can simplify. Plus or minus 2I root 2. All right. One should not be too bad for us. Then number 8, remember the quadratic equation. Quadratic formula can be utilized, and that is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Where are we getting those? Because that's ax squared plus bx plus c equals 0. All right? Got to know that. Got to have that down. So first off, I ask myself, because if it can factor, I want to factor it. What multiplies to 4 and differs by 2? Only way to get 4 is 4 and 1, and 4 and 1 differ by 3. This can't factor. So x equals the opposite of 2, plus or minus the square root of 2 squared minus 4. A. C is a negative 4 all over 2a. You're going to have 16. You're going to have 4 plus 16, which is 20. The square root of 20 is 2 root 5. Divide this, and this by 2. That's a negative 1. It doesn't go bye-bye. For some of us in the quiz we let it go bye-bye. It does not go bye-bye. Maybe that was in a homework set. Anyway, it's negative 1 plus or minus root 5. Nice. One's not. Again, pause this whenever you need to. I don't want to make 30-minute videos. All right. Recommendation I would have on number 9 is to multiply everything, set it equal to 0 and multiply. So set it equal to 0 and then multiply by negative 1. You want that leading coefficient to be positive. If not, you're likely to make a mistake. All right, so now I'm going to have 2x squared minus 4x plus 3 equal to 0. Here's what the AC method can do. If you're going to try to factor it, you say, what multiplies to a times c? 2 times 3 is 6. Can you think of 2 numbers that multiply to 6 and then add to a negative 4? And you can't, because that would be like negative 3, negative 2. Gives you negative 5, negative 6, and negative 1 gives you negative 7. So it's not going to factor. So x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. We're going to have 16 minus 24, which is a negative 8. Ding, ding, ding. Can't leave it like that. So if you want to call it plus or minus I root 8 first and then break it down as plus or minus 2I root 2, that's fine. You want to divide this, and this by 2. Remember, the 2 on the inside is protected. Can't touch it. Okay? Again, none of that is new. None of that is new. Let's talk about number 10. 4 times 3. I'm just going to check. Obviously, guys, you saw that I had to do the quadratic formula. But in real life, you can check. 4 times 3 is 12. Can you think of two numbers that multiply to 12 and add to 4? They got to do both. So like 6 and negative 2 wouldn't count because it multiplies to a negative 12. So I can't think of two numbers that multiply 12 and positive 12 and also add to 4. X equals the opposite of b, negative 4 plus or minus the square root of b squared minus 4ac all over 2a. 16 minus 48 is a negative 32. So you're going to have plus or minus I root 32, which is 4 root 2. 4 root 2, it's 16 and 2, and 16 is 4 and 4. Again, the TI-30 XS multi-view. It's very helpful with this. Make sure you're in math print mode. I can divide this, and this by 4. All right. And then 11, a lot of I's. Again, 2 times 5 is 10. Can you think of two numbers that multiply to 10 and add to 4? No, you cannot. So x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. 16 minus 40 is a negative 24. So it's going to be plus or minus I root 24. All right. Which is 2 root 6. Make sure the I is there. Then I can divide this, and this by 2. I don't know. So you're not getting 5 of those, but I'd expect 3 or 4 of them. Quadratic formula for a lot of them. All right, then we're going to solve each inequality. Okay. So it's like the first page, 4 through 6. Again, just check. Can I have a distance that's less than 1/2? I can. That's a small distance, but that's all right. So I'm going to set what's inside the absolute value. Or I'm not going to set it equal. I'm going to say it's less than 1/2. And then because you could live 1/2 to the left, so you're calling this a negative 1/2, you really multiplied an inequality by a negative. You got to flip the sign. And then you just solve the inequality like you would. You're going to subtract 4 from 1/2. You're going to subtract 4 from a negative 1/2. You're going to divide by 3. You're going to divide by 3. All right, so you guys can most definitely handle that one. So you got 12, and 13 might actually be easier than 12 here. You're going to take 2x minus 5. It's going to be greater than or equal to 9. Right, just drop the absolute value. Write exactly what you see. And then you're going to say 2x minus, you're going to say 2x minus 5 is less than or equal to, flip the sign, negative 9. Add 5, divide by 2. Add 5, divide by 2. Yay. Number 14, first thing I do, subtract 2. All right, then I pause. I have some distance. Less than or equal to 2, is that allowed? That is definitely allowed. So I'm going to take 2 minus 3x. I'm going to say it's less than or equal to 2. I'm going to say 2 minus 3x is greater than or equal to negative 2. All right, going from 2 to negative 2, I've multiplied by a negative 1, so I have to flip that inequality. I'm going to subtract 2 from both sides, but then I'm going to divide by negative 3. So if you divide by a negative, you got to flip that sign. I'm going to subtract 2 from both sides. I'm going to divide by negative 3, so I got to flip the sign. All right, let's take a look at 15. I'm going to subtract 1. All right, then I'm going to divide by negative 1. I'm going to divide by negative 1, which gives me, in the absolute value, 2 minus 3x again is greater than 5, and that is allowed. Now, if it said 2 minus 3x in the absolute value is less than negative 5, like it did here, before I divided by negative, then I would say no solution. I don't say no solution. So I take what's inside the absolute value, I call it greater than 5, take what's in the absolute value, I say it's less than negative 5. Subtract 2, and then I divide by negative 3. Divide by negative 3. All right, when I divide by negative, gotta flip that sign. Flip that sign. Awesome. Again, you guys can handle all these. Can handle a lot of this. This quiz is a review from college algebra. All right, I got the absolute value all by itself. So I say what's inside the absolute value is less than 2. I say what's inside the absolute value is greater than negative 2. Multiply by 4, then subtract 3. Multiply by 4, subtract 3. That one's shouldn't be too bad. I know you got a fraction, but should not be too bad. All right. We're going to add 4 to both sides. We're going to say 3x minus 2 in the absolute value is greater than or equal to 7. 3x minus 2 in the absolute value is less than or equal to negative 7. I'm going to add 2, divide by 3. I'm going to add 2, divide by 3. All right. 17 should hopefully be pretty easy. It's just like 14. Don't have to divide by a negative, though. All right. Honestly, just one more step than 13 is. Easy question, I'm hoping. Then, all right, we talked about this. I would expect one, I don't know, maybe 2 of these. All right, so the price P in dollars and the quantities sold of a certain product obey the demand function X equals 1,500 minus 10P. So find a model that expresses the revenue R as a function of P. So that means it's got to be R of P, all right? P has to be the independent variable. So we take the price, and this is the demand, all right? So that's how much we're going to sell, and we multiply it by the price. We take this and we multiply it by the price P, and then this is our function. R of P is equal to this. You're just writing an equation. Then what unit price should be used to maximize the revenue? Again, because it's a negative P squared, which is a negative X squared, it's going to make an igloo, which has a vertex. That is a maximum value. It's just a vertex question, guys. It's a vertex question. So you would have had vertex questions when you graphed last quiz. So remember, the X coordinate in the vertex is negative B over 2A. All right, so remember when we have the quadratic formula? It's this part right there, negative B over 2A. So I'm going to say the opposite of 1,500 over 2 times a negative 10, $75. Nice. Then what is, so I'm asking you what the vertex is, but over 2 questions. So then what is the maximum revenue? I'm going to take 75 and plug it in for P there and P there. All right. And that makes sense. It's quite positive. And then how many units are sold at this price? So using a P value of 75, I go back to the original demand question, which is right to the demand function, that is, and I plug 75 in for P. 1,500 minus 10 times 75. Nice. All right, if you guys go into finance, major in business, you'll see some of that later on. All right, so this is the cost function. All right, so this is going to make a U because it's a positive X squared. That makes sense, guys. The vertex is a minimum, and you want to minimize cost. You want to maximize revenue, minimize cost. So how many golf clubs should be manufactured to minimize the marginal costs? Again, it's negative B over 2A. That's B. So, all right, it's the opposite of a negative 614 or 617.4 all over 2A. I divide, I get 63. All right, 63 clubs, 63 clubs. And then what's the marginal cost? All right, so plug 63 in. What is the actual cost? C of 63 is 4.9 times 63 squared minus 617.4 times 63 plus 19,600. Anyway, there it is. So what is the marginal cost? That doesn't seem too bad. Nice. All right. Hopefully that was done correctly. Oh, sorry. Just plug it back in. Nice. So no equation, no function had to be built in that one. All right, pause this whenever you need to. This one's going to be probably 21 or 22 minutes total. All right, so this one is like 20. Instead, though, the independent variable being P, it's going to be X. So that's the demand function. P is that. So this is how many you sell. And then as a function of X, right? So it's going to be X times this demand function. Yeah, so think of this as the price, and this is how many you sell. Remember, revenue is always the price of what you're selling by how many you sell. That's it. All right, think of any fundraiser you have, or anytime you're doing concessions. Water costs $2, you sell 50, that's $100. This is the price, that's how many you sell. So it's going to be X times the price, distribute, and then it's R of X. All right, it literally says a function of X. I got to tell you, function of X or P. Again, this will always be your independent variable, whether in 18 it was P or in this question number 20, it's X. All right, so that's the function. And then what is the revenue if you sell 400? So I just take 400, plug it in for X there, and plug it in for X there. Okay. So we're not asking to maximize revenue here. We're just saying if we sell 400, what is the revenue? All right, then here we have what quantity maximizes revenue. All right, so now it's vertex time. We say the opposite of B over 2 times A. Now that's negative 1/10. So you can call this, as we talked about in class, you can call it negative 1/5, or you can call it negative 0.2. It doesn't matter. Negative 1,000 divided by negative 0.2, that's going to give you 5,000. All right, so that's the first part. In 18, it gave this was 2 different questions. So that's the quantity that maximized revenue. Then what is the maximum revenue? We're going to plug 5,000 in for X here and here. $2.5 million, which is a lot more than just under 400,000. All right. And then what price should the company charge to maximize revenue? We go back to that demand equation. So we said that 5,000 was the X value that maximizes it. So we plug 5,000 in for X right there. All right, we'll get 500. All right, folks, I got like 14 or 15 questions on your quiz, so they didn't all make the cut, but any question that's on here can be on your quiz. We can do well. We just need to prepare. This is Yak Math Videos, signing out.